So last time we talked about inferential statistics and placed the emphasis. We said that inferential statistics is a type of statistics where you need to draw conclusions from the data that you're given. Then I also said that there are two types of statistics mainly. We have inferential statistics and descriptive statistics. So as for today, I want us to have a look at descriptive statistics. So the central tendency is the extent to which all the data values are grouped around a typical or central value. So when we say the measure of central tendency, we are just trying to ask ourselves to what extent are the individual scores or are the values grouped around the mean to be specific. So that is what we mean when we are trying to measure the central tendency. So the measure of central tendency is actually the measure that helps us to understand the extent to which all the data values revolve or group around the central value or the mean. Okay. Okay. So the variation is actually the amount of dispersion or scattering of values. So that is what variation means. So we are asking ourselves on how scattered are the individual scores, how scattered are the values. That is the measure of variation. Then you find that the data set that you are given always exhibits some shape. So the shape is the pattern of the distribution of values from the lowest value to the highest value. So the shape will give us how our data is distributed, okay, especially from the lowest value up to the highest value. So the first measure of central tendency that we look at is the mean. So to be specific, we are looking at an arithmetic mean, which is basically found by summing up, okay? The mean is basically the summation of the individual scores, summation of X values divided by what? By N. This is the same thing as said. So you sum them X1, X2, X3, X4, X5, and then you divide by how many they are, where X represents the individual scores, okay? Okay, now what you observe is that when you're measuring these values, you find that some values are far from the mean, okay? There are some values that are far from the mean. So take, for example, you have some numbers from 1. Yeah, your numbers are distributed from 1 through up to maybe 20. So then when you see these numbers that are distributed, you calculate the mean. Maybe you find that the mean is just around let's say 12, okay? Then you see that you have some numbers that are far from the mean. When you measure them from the center, they are far from what is from the range captured. So those numbers that are far from the mean are what we call the outliers. The extreme values are called outliers. Is that okay? You're not giving me feedback. I don't know.
Me?
Hello?
Can you get me?
Yeah,
Hi.
I can get you now. I think your mic had been mute. I like it that whenever I move, I'm confirming time again and again, being online, that people are following.
Oh, okay. I wanted you to come again on the outliers.
Okay, so outliers, these are extreme values, okay? The extreme values are called outliers. So by extreme values, what we mean is that you can be having numbers, like let me just give numbers, maybe 2, 3, 4, 5, 5, 6, 7, 7, maybe 3 sevens, 8, 9, then you have a number like 18 and 31. Okay, So what happens is that now when you calculate for the mean of these, the center, you find that the mean will be around the most frequent number. Maybe your mean will be somewhere around 7. You get it, right? Then you will have, your mean is 7. You have some numbers that are far from 7, like that one. That is far, very far from the center. Okay, we call them the extreme values or the outliers. Is that okay?
Yes, I got it now. I understand now.
Okay, you'll get it more clear, especially when you do an example under whiskers and box. Yeah. So that's what it actually means. So then when you talk about the median, obvious, this is the number that is in the middle, you know, of the values. You arrange the numbers from the smallest to the what? To the biggest, right? Then you get the median. So how you get the position of a median? The position of a median is found by saying the number of individual scores plus 1 divided by what? By 2. Okay. How many individual scores do you have? How many are they? What is your sample size? Then after you have allocated your number, you have arranged your number from the smallest to the largest. So you divide the sample size plus 1 divided by 2, and that will give you the position, okay, of the median. Okay, the position of the median. Is that okay?
Yes, it's okay.
Now, when you find the median, this position, you find that sometimes you find a number that is an odd number. Now, an odd number is a number that is not divisible by 2, okay? Numbers where 2 leaves a remainder is 1. Says 3, 5, 7. If you find that the answer that you find after dividing is an odd number, then the median is actually, oh, sorry. What I meant is that if the number of values, okay, the n, like nn, is actually the odd number, then the median is the middle number, the number that is in between, okay? So that is if you have got sample size, when you arrange them, maybe 2, from 2 up to the last number, then you find that when you count them, they give you an odd number as n. If n is an odd number, okay, that number that is in between is called the median. Is that okay?
Yes,
So what we mean by odd numbers, you can have numbers like, let's say 2, 3, 4, 5, 7, and 8. How many are they? 1, 2, 3, 4, 5, 6. There are 6. Let's put another one, maybe 1, so that they are odd number. This is what we mean by odd numbers, okay? So it means this number which will be in the what? In the middle, right? This number which will be in the middle after arranging them, that is called your what? Your median. But what if the two numbers are even? You have to average them, okay? Instead of having an odd number, then you have an even number. Now, an even number is basically a number that is divisible by 2. So you have how many individual scores? Let's say you have 6 individual scores now, right? So the two numbers here will be at the center. You add them and they divide by 2. Did you get that?
Yes.
Yes, that would be your mean, your median, sorry, not the mean. The mode is the most frequent number. I think I said that already. The number that appears many times. I think we had that under that example, isn't it?
Yes, we did.
So that is what is actually there. Then we look at the measure of variation. Fast forward, we have the measure of variation now. So the common parameters that we use under the measure of variation are the range, the variance, the standard deviation, and the coefficient of variation. So the measure of variation actually will give us the information on the spread or variability or dispersion of the data. So listen, the central tendency will explain to us to what extent are the individual scores grouped, okay, like at the center, right? That is the measure of central tendency. Those measures of central tendency, the mean, the mode, the median, all of them, they give us the central, they explain more about the central tendency. But when you talk about the measure of variation, we're talking about these, they'll explain to us, or they give us the information on how dispersed are the data values. Okay, how dispersed, like how distant are they from each other? Did you get that? Yeah.
Yes.
Maybe you're measuring the age of people. So you find that maybe the age difference is 10, maybe 15 age difference. Like there are those huge differences in between the individual scores. That is what the measure of variation seeks to find. Okay. All right. So now, how do we find the range? The range obviously is the largest number minus the smallest smallest number. Okay. So how you find the range? You say the highest score minus the smallest score. Did you get that?
Yes.
Hello.
Yes, I got it.
Yes. So the largest score, when you have the number, you examine them, which one is the biggest number among them? So that biggest number minus the what? The one which is the smallest, then what you get is the range. Okay. The range does not care about how the data is arranged. Okay, it is not concerned about whether the data is arranged from the smallest to the largest or from largest to the smallest. No, it does not just care about that. Okay. Did you get that?
Yes.
Yes. So now let's look at the other measure, which is the measure of the variance. Hello?
Oh, sorry. Yes, please.
Okay. Yeah. So the variance actually gives us the average of the square deviations of values from the mean. That is what variance measures. So you get these formulae so that when we solve a question, at least the question cannot seem to be very strange. So we are saying the variance, the sample variance is given us the summation, okay, of x values minus c, x bar the mean. Then you square that, you divide by n minus c, 1, like that. That is for the sample variance. Did you get it? So where x is an individual score, okay, an individual score, and the x bar is the mean. So you'll be subtracting from each individual score minus the what? The mean. Okay, then you square that and you keep on adding until you finish all the individual scores. Then you will divide by the sample size minus 1. Did you get that?
Yes, I did.
Okay. If you got that, I would request you to follow nicely, because we want you to understand when you start solving with lessons what we are doing. So the whole idea of running you through this is just that you at least have a glimpse understanding of what you are going to be doing. Then
Able to turn back to the last page. There's something I've missed.
Okay, this one. You're talking about this one?
Yes, that's this page. I was just looking at the formula.
Or the formula. So basically, it is the summation of x minus c, x bar, you square that, divided by n minus 1. That is what you get. Summation means adding all these deviations. Okay. So in practical sense, variation measures how distant are the individual scores from the mean again. So that is what variation means. The distance, the deviations, it measures the deviations, the differences of an individual score from the mean. Okay, how far is this individual score from the mean? How far is this one from the mean? That is the what variance and the standard deviation together measure. So they explain to us how far is the individual score from the expected value. You know that the expected value is same as the mean, right? It is the other name for the mean. The expected value is the other name for the mean. Is that okay?
Yes, please. That's okay.
So for example, if you're looking at the mean age, if the mean age maybe of the students is just 21 years, right? We say that those are maybe first year students or second year or third year students. Let's say third year students have got the mean age of 21, right? You find that not everyone is 21
Hello?
years old. Hello.
Hello?
Hello.
Hi. You need to just give me a second. I need to speak to my boss. I'll be back soon.
Oh, okay.
Thanks.
Okay. I was saying the standard deviation as well measures the variations about the mean. So it has got the same measure as that of the variance. So it's only that what it does, it square roots the variance. So it's just the square root of the variance. That variance you have found, just square rooted. If you've observed, this formula is just the same, right? As the one that we had for the variance. Then you just square root the variance. When you square root the variance, you find the standard deviation. Did you get it?
Yes.
Yes. So the higher the standard deviation, or the smaller the standard deviation, the better. Okay, because it shows us that at least the individual scores are not far from what? From the expected value. Okay. All right. Here is the issue of the Z-score as well. The Z-score. You remember the Z-score? I think I talked about the Z-score. Yes. The Z-score is here again. So you have the Z-score. It is calculated by removing the individual variable minus the X bar, which is the mean. You divide by the standard deviation. The good example that we have is that if you have the mean score of 490 with a standard deviation of 100, then the question is that can you compute the Z-score for a test score of the score is 620. So in short, we are looking at the scores, right? The scores. So there is a score of 620, and then the mean of the scores, right, is 490. Then the standard deviation there is 100. So to find the Z-score, you say X variable, which is a score, which is 620 minus what? 490 divided by the standard deviation 100, and you have 1.3. So the interpretation is that this value, okay, this is 620, is 1.3 standard deviations above the mean, okay? And it would not be considered as an outlier because it's not very far from the mean. Did you get that?
Yes.
Yes. So that's what is there. All right. What is it that we can talk about that is necessary? Okay, still the way how we found the mean of the sample, we can still find the mean of the population as well. It is still just the summation of X variables divided by what? Divided by N now, the sample, the population. Now, you know there is a difference between the population and the sample. So when you're dealing with the sample, you subtract the sample size -1. But if you're dealing with the population, the whole population, you don't subtract 1, you just divide, okay? But most of the times we find we use sample because it is difficult to calculate for the entire population. Got that?
Yes, I have.
Yes. So therefore, the symbol that we use for the population mean is mu, like this one. This is the population mean, whereas the sample mean is X bar. So they are both means, but the mu is actually the standard deviation, the mean for the population. And the N is given as the sample size.
Give her a 10, coach. Give her a 10. Just one. Huh? One. One what?
Hello?
Hello?
Okay, we proceed.
Yes, please.
Okay, so the population standard deviation as well is found in the same way how we find the sample standard deviation. It's only that the parameters that you use are just from the population now. Okay, it's only that I said that for the population, you don't divide by n-1. Instead, you just use the entire n. Otherwise, you square root the variance, you find the standard deviation.
I am not paying. I've told you I'm not paying.
Okay. Now, what about the quartiles? Okay. So the quartiles, what they do, they rank, they split the ranked data into 4 segments with an equal number of values per segment.
Okay, bye.
Okay.
Karen, I'm here. You can go on.
Okay. So the quartiles actually will split the ranked data into 4 segments with equal number of values. So what the quartiles will do, will try to divide the data that we have, into equal portions, actually 4 of them. So 25, 25, 25, when you sum all 25 times 4 is 100%. So the first 25 is quarter one. So quarter 1 is 25%, quarter 2 is 50%, 75% is quarter 3. Okay, we don't have quarter 4. We just have 3 quarters, quarter 1, quarter 2, and quarter 3. Is that okay?
Yes, please.
So the first quartile is the value for which 25% of the observations are smaller. Okay, and the 75% are larger. And the quarter 2 is the same as the media. It's in the middle of the data. That's quarter 2. And only 25% of the observation are greater than the third quarter. So third quarter, which is 75%, only 25% is greater than 75% to 100. Okay. How do you locate the quartiles now? This is what I was talking about. You pay attention to this one so that you can understand how we do the whiskers and box. So to find quarter 1, you just say the sample size n+1, you divide that by what? By 4. The sample size that you are given, how many they are, you count them. Then you add 1 and you divide by 4. That will give you the position of the first quarter. You get it, right? It is just a position where that first quarter is. This is very important to learn and notice. You'll use it most or frequently. Quartile 2 is given as n+1 divided by what? By 2. That's quartile 2. And whereas the quartile 3 is given as 3/4 times what? n+1. By the way, this is same as what I've just written here. It's just one and the same thing. Okay. So that's quartile 3. That's how you find quartile 3. You say 3/4, which is same as 75%, right? Multiplied by n+1. That will give you the position for the what? For the third quarter, and n is the number of observations. Okay.
Yes, please.
So now, what are some of the rules that we use when you are calculating the quartiles? Okay. So when calculating the ranked position, we use the following rules, and you pay attention to the rules. The first rule is if the result is a whole number, okay, for the position, when you calculate that n+1 divided by, if you find a whole number, okay, then it is the ranked position to use. So if you find a position number, maybe 6, That simply means when you go back to your data that you have arranged from the smallest to the biggest, right? The one that is on position number 6, it is the first quarter. Did you get it?
Come again on that.
I was saying when you calculate for the quarter, let's say quarter one is equal to 1/4 times n plus 1. When you calculate, this n is the number of observation, how many there are. So when you calculate, you solve, you find that maybe the number is 6, is a whole number, okay, in short. So this simply means the position of the first quarter is position number 6. So the score, which will be on position number 6, that's the one that you regard as the first quarter, right?
Okay, I get it.
Yeah. So this one just gives you the position. That is if it's a whole number. Then if the result is a fraction, okay, maybe 2.5, 2 point, it's a fraction. Then you average the two corresponding values. For example, you find the 2.5. It means that the number that you find, your position is in between 3 and what? 2 and 3, right? 2.5 is between 2 and 3. So the individual score that will be between position 2 and position 3, you add them and get the what? The average. Did you get it?
Yes.
Yes, you average them. So you go, this one is just giving you the position. Then you go to those numbers that you arrange from the smallest to the biggest. You check for that one which is on position 2 and the one on position 3. You add them and divide by 2. That is how you deal with it if you find the fraction like that one. But what if the result is not a whole number and it's not a fraction? Take, for example, you have 2.13 or something. This is not a fraction. So how do you do it? Or maybe 2.4, 2.3, 7.7. How do you do this one? Okay, this is what you do. The rule is, if the result is not a whole number, not a fraction, okay, or it's not a fraction half, then you round up the result to the nearest integer to find the ranked position, okay? You round up. So for example, you have 2.7. You round up this to 3. Did you get that? Hello?
I'm here.
Yeah, unless you just find the 2.5, that's when you average the 2. But if you just find a number that is less than that, you round up. If you find maybe 2.3, you just round up to 2, because 2.3 is you can't add 1, you understand? So only when it is 2.5, that's when you average. When it is how would I say, the fraction half, okay?
Yes.
Did you understand?
Yes, I do.
Okay, if you did, that is okay then. So here's an example. The example is simple. You have got a sample data that has got this outside arranged from 11 to 22. So we want to find the first quarter. So the first quarter is found by saying, what number is that? Okay, the first quarter is found by saying 1/4 what? 1/4, or 1/4 n plus what? Plus 1. These are 9, right? So you say
Yes.
1/4 times 9 plus 1 is 10. 4 into 10 is 2.5, which means the position that you're looking for, it is in between 2 and 3, right? So you go on position number 2 and 3. The one that is on position number 2 is 12, right? So it is 12 plus 13, you divide by 2. So your first quarter is 12.5. Does that make sense now with the use of numbers?
Yes, it does.
Yeah. So you just keep on doing the same for everything and following these rules, then you will be fine. The interquartile, I said, is quartile 3 minus what? quartile 3
One.
minus quartile 1, that is interquartile range. Whereas semi-interquartile range is interquartile range divided by 2. Okay, find the interquartile, then you divide it by 2. That is semi-interquartile range. The whiskers and box is this one that you are seeing. Okay, how you find it is to find the minimum value from the numbers that you found. This minimum value was what? Was 12, right?
Uh-huh.
The minimum value was 12. Then you write quartile 1. The number that is quartile 1, you write the number for quartile 1. And the one that is quartile 2, you write it. And for quartile 3, you write the number. Okay. Then for the maximum value, you write. So now, listen. Here is a formula for the whiskers and box so that you understand, because this one seems to be confusing a bit. This is how you do it. This is, do I have an explanation? I don't have here. Okay, it's not explained. Let me explain, Cash. It is done like this. For you to find this smallest value here, smallest value is found by saying quartile 1 minus 1.5 times the interquartile range. Interquartile range. Did you get that? That's how you find this value here. Okay. Quartile 1 minus 1.5 times the interquartile range. You should have already calculated for quartile 1, not the positions, please, the actual interquartile. And you'd have found already the quartile 1, the figure that should be on quartile 1, that is the one that you put here. Okay. Then you put the quartile 1 here, the median, which is quartile 2 here, and the quartile 3 here. Then the largest, which is the largest value, right? The maximum value. The maximum value is found by saying quartile 3 plus 1.5 times the interquartile range. Did you get that?
Yes.
I'm explaining slowly here because you need to pay attention.
So where does the 1.5 come from?
Yes, that's a formula. Yeah, on average, that's how you.
Formula. Okay.
Yes, that's a formula you can use to find the smallest value, because it's like the lecturer didn't show us how to find the smallest value. He just wrote the smallest value. It doesn't mean that the smallest value on those numbers you get, because you see the way how this is presented. Where is it? This kind of presentation, you've seen. It shows that the smallest value is 11, right?
Yeah.
And the biggest value is 12.
Yes. Hello? Arion, are you there?
You don't put 11 the smallest value. Be found by, that is the biggest value. You also calculate for it. Captured will range from the smallest value to the what? To the largest value. Now, any number, listen, any number that will fall outside the smallest value and outside, or that will be below that will be smaller than the smallest value and the larger than the largest value, those are considered as what? Outliers. Do you get it now? So outliers are numbers that won't fall within this range. Aye. Hello?
Yes, Arion, I can get you.
Yeah. So I've said the outliers, any number that will fall outside this range that we have said, smallest value and the largest value. So if your largest value is maybe, let's say 60, then you find a number like 81. It is considered to be an outlier. They fall outside the covered range. Okay. Here maybe a smallest number is 2. Let's say it's 4. then you find a number like 1. Okay, 1 is an outlier, it's outside the range. I think you have understood now the concept of the outlier. This is how you do the box plot. And it's one of the ways that we use to do what? To present data, right? From what we said last time, we said you can summarize data using the whiskers and box. It is also called the box plot, or the whiskers and box is the same thing. Okay. Hello.
Hi. Hello.
Okay, so I was saying, now the distribution of data is explained from, we can still derive the explanation from the whiskers and box. So if you find that the whiskers and box has got the largest tail to the left, then you say that the data is left skewed. Okay, what it means that from the smallest value here up to the center, the mean here, then the distance from the mean here, the center, the median, up to the last value here is shorter, then here it is longer in terms of the values. You will see that the data is highly distributed to the left. Hello? Hello?
Hi, Arion, I'm here.
Yeah. Then if you find that the distance is equal from the median here up to the smallest score, and from the median up to the highest score, the distance is just equal in terms of the numbers, then it means your data is what? Symmetric. But if it is longer going to the right, the distance is a lot here, it means that the data is right what? Right skewed. Okay? Hello.
Hey, I'm here.
Okay. Covariance measures the linear relationship between two numeric values, or the two variables, the values of x and y, and it is found by summing up the relationship between the x individual score minus the x bar, the mean, times the y individual score minus the y bar, like that, and you divide by n minus 1. That's how you find the correlation. So you are given two variables, the y variables and the x variables. Then you calculate like this. You sum up on top and divide by n minus 1. So you get the answer. That's how you find the covariance. Okay. It measures the strength of the linear relationship between the two, would say, numerical variables. Okay. Hello.
Hi, Arion.
We are fine?
Yes, we're good.
Okay. If you are good, we continue now. How do you interpret the covariance? So if you find that the covariance is greater than 0, which means it's positive, it means that the two variables tend to move in the same direction, which means there is a positive relationship, okay? Which means that if this variable increases, even this other one does what? Increase, right? But if the covariance is less than 0, which means it's negative, right? If it is negative, it means that these two variables, x and y, they move in an opposite direction. Technically, you can say they have an inverse relationship, okay? Which means when this one increases, the other one does what? Decrease. And again, if you find that the covariance is 0, it means that the two variables are independent, meaning there is no relationship whatsoever between the two variables, the dependent variable and the independent variable. Did you get that? Hello.
Yes, I did.
Okay. So basically, these are just the same things. So you find that graphically, the relationship is depicted. I would say if there is a positive relationship, when you graph the two variables, the x, y, you find that your line will move straight. Your plot will be moving upward like this. This means there is a positive relationship. But if your lines move downward like this, then when you draw a fitting line, it is like a demand curve, then it shows that there is a what? An inverse relationship, which is a negative relationship. When this one increases, the other one does what? Decrease. Okay?
Yes, please.
But if you find that the lines are fitting straight like this, so that when you draw your line, it is horizontal, it means there is no relationship. It means that the covariance is equal to what? To 0. Okay? Or the correlation is equal to 0. This time around, I call for questions. Do we have any questions?
Yes.